I'm going to continue with 4 more examples of the square root property. Just starting off, just giving you a variety of different things you might see as you solve these. It's obviously not going to give you every possible type of problem because there's a lot of them, and it's good for you guys to struggle with some of these on your own too. But this gives you a pretty good variety of different things. So the first one, we'll start up here in the top left. This first one, we always, with the square root property, need to isolate that square term, so that square part. So the x squared here, the x squared, the x minus 2 squared, and the 2x minus 1 or plus 1 squared. Okay, so each of those squared parts. So I'm going to add the 6. We always want to get rid of the constant term if there is one. This gives us 5x squared equal to 6. And then divide out the 5, and we're going to have x squared is equal to 6/5. Now we apply the square root property, or some of you might say take the square root of both sides. Whatever makes sense to you. I like the square root property. So then x is going to be plus or minus the square root of 6/5. Now, problem is, this is an irrational denominator, and remember in the previous chapter we rationalized denominators. So we're going to go through that process to rationalize this so that we don't have a root on the bottom. This is going to be the preferred solution in your textbook and on my math lab. Alright, so we're going to think of this as the square root of 6 divided by the square root of 5. Remember, to rationalize a denominator, you multiply the top and bottom by that denominator. Okay, and so you're going to end up with still plus minus. On top, root 6 and root 5 combine for a root of 30. And on the bottom, root 5 and root 5 combine for just a 5, right? It's the square root of 25, which is 5. Okay, and so the square root of 30 does not simplify. There's no perfect square factor, and so this combination or this expression is the simplest form with a rationalized denominator. So our final solution set will contain the positive and the negative root 30 over 5. Okay, and that is valid. That is what we're looking for, even though it looks kind of ugly. That is what we're looking for. All right, in this next example, it's going to look a lot similar to the previous one. We're going to start out just by subtracting the 15. Then we get 4x equals negative 15. I'm sorry, 4x squared equals negative 15. Divide out the 4. You're going to get x squared equals negative 15 over 4. And then here again we apply the square root property. Okay, so x is going to be plus or minus the square root of negative 15 over 4. Now, fortunately, on the bottom I have a perfect square, so I could split this root to the top and bottom and actually call this the square root of negative 15 divided by, that's not supposed to be a 4. It's actually divided by 2, right? The square root of 4 is 2. Cool. Now there's a problem. I've got a negative under the root. It's not really a problem now because we've learned how to deal with complex numbers. And so the negative under the root is really just an I. So this actually simplifies to I times the square root of 15 all over 2. Okay. Probably want to write this with the I in the back. So it looks kind of like our a plus bi form for complex numbers. So I'm going to finish this off. I'll go ahead and put it right into the solution set just because I'm running out of space here. And we're going to have the positive or negative root of 15 over 2 times I. That should give us our solution. Okay, and it is complex. So there's actually two complex numbers there. All right, now let's look at the third example. We'll go right there's good. Again, I got to get rid of the constant first. That way I can get my square root in. So I get x minus 2 squared equals negative 4. I'm going to use the square root property. I get x minus 2 equals plus or minus the square root of negative 4. Well, what is the square root of negative 4? Again, that's a complex number. It's going to be plus or minus 2i. Remember, the square root of the negative makes the I, the square root of the 4 makes the 2. We simplified these in our last section. Okay, and then finally, I'm going to add, well, maybe I'll rewrite this so it looks a little bit cleaner. X minus 2 equals plus or minus 2i. I need to add the 2 to both sides. Okay, they'll drop out on the left, and so x is going to be equal to 2 plus or minus 2i. That is the simplified form. There's nothing else I can do to combine these because they're unlike terms. It really gives us two complex solutions, 2 plus 2i and 2 minus 2i, and those are actually conjugates of each other, which we talked about before as well. So our solution set is a pair of complex conjugates, and I'll just write them together, 2 plus 2i, but you could separate them, and in fact my math lab may want you to separate them, so I'll even write it here just in case. They may want you to write this as 2 plus 2i and 2 minus 2i. I don't know how that's going to look on my math lab, so just keep in mind that that's a possibility. Okay? Alright, final problem here. Again, trying to isolate this quantity squared. So I'm going to multiply both sides by the 3. Right, that'll cancel the 3's out, and we'll be left with quantity 2x plus 1 squared equals 24. When I apply the square root property, we'll get 2x plus 1 equals plus or minus square root of 24. We simplify that root, that will become 2x plus 1 equals plus or minus. Now remember, 24 is really, what's that, 4 times 6? 4 is a perfect square factor. And so the square root of 4 is 2, and the square root of 6 doesn't simplify. So there's our simplified form of the root of 24. To finish this off, I got to get x by itself. So we're only about half done, maybe a little more than that. I got to subtract the 1 from both sides. 2x will equal negative 1 plus or minus 2 root 6. I've got to keep these separate now because they're unlike terms. One has a root and one doesn't. Final step, we got to divide out this 2. Now when I divide the right side by 2, it distributes to both terms. So I end up with x equals now negative 1/2. Plus or minus stays. And then I get 2 root 6 over 2, right? This denominator of 2 splits to both terms. It distributes. I can cancel out these 2's, and I get negative 1/2 plus or minus simply the square root of 6. And so that will be my final solution. Negative 1/2 plus or minus the square root of 6. And again, I'm not sure how my math lab is going to prefer that, whether they're going to want you to split it up into 2 answers like here or keep them together. Either way, I'm fine with either one when you put these in on a test. Okay?